and welcome back to my YouTube channel, friends. A lot of learnings today. So let's begin with data structures. The topic I'm going to explain to you all today is sparse matrix multiplication with data structures using C. So what exactly is sparse matrix? A sparse matrix is the matrix in which most of the elements are 0. To store all the elements of the matrix leads to a wastage of memory. So it is better to store the data of only those elements which are non-zero in the existing matrix, because the 0 elements which are going to be stored are anyway considered to be null. Hence, we store only the non-zero elements into it. For example, let's suppose there is a matrix A of which most of the elements are 0. So, to store the matrix, what we do is, it is better to store only those elements which are non-zero. If the matrix is a 2 cross 2 matrix and 3 of the elements are 0, we are going to store only the element, a single element that is non-zero. So using this way, what happens is we can store the matrix such that it reduces the space and takes lesser time to perform the operations, because the 0 elements are anyway going to be considered null, as we are going to be representing it in an array form. Let's talk about it further. One of the operations is the multiplication of two matrices, in which we have to multiply two sparse matrices. So to store the elements that are non-zero, as I told you, we are going to use the below two representations. These are the two different representations by which we can represent a sparse matrix. The first one is an array representation, in which we are going to be using an array, and the second one is a linked list representation. Let's go learn it on brief. So in the array kind of representation, where we need to access the elements more often, since the array stores the elements based on the indexes, thus it is much helpful, because the traversing of the elements when we have arranged it in an array kind is very easy when compared to the linked list. So the 2D array is going to be converted to a 1D array with 3 columns representing the sparse matrix. The next one is a linked list kind. When we talk about a linked list kind of representation, where the frequency of insertion or the deletion operation in the matrix is more, it is very easier to insert the element or delete the element, because we are going to represent the sparse matrix elements in a linked list. So insertion or the deletion of a element in the list can be done easily when compared to arrays. But when we see through the arrays, traversing is easy. So here is a small blueprint of how we are going to represent the matrix in an array kind or in a linked list kind. Firstly, in the array kind, the row or the row index of the non-zero element, then we are using the column, that is the column index of the non-zero element, and then the value at the same row and column index in the 2D matrix. As the box shows, firstly we are going to put the value of the non-zero element, then the row number, and then the column number. In the linked list type, it is more of a node representation. Here, just like the array kind, we are going to use the row index, the column index, and the value of the 0 element. With all these, we are going to add an extra thing, that is the next node. We all know that the linked list contains a pointer at the end which points to the next referential node. So here in the linked list representation, we are going to be using the value, row, column, and the next node pointer, of course. Here is a stepwise guide of how we are going to multiply the two sparse matrix. So the step 1 is we have to firstly take the transpose of the second matrix. So the transpose of the second matrix is converting all the rows into columns and all the columns into rows. So here we are going to store only the non-zero elements because, as I told you, it is a sparse matrix. So we have to replace all the rows and columns with each other. In the next step, in the resultant matrix of the multiplication of the two matrices, let X be the row of the first matrix and Y be the row of the transpose of the second matrix. We get the resultant as X into Y. For example, the resultant X into Y is going to be the summation of the values we get after multiplication of the two values, in which the column is the first matrix and the column in the transpose of the second matrix is the same. Then get after the multiplication of those values in which the column is the first matrix and the column in the transpose